Hello, my name is Will Simonson, and today I will be going over Physics 2 Lab 1 on charge tape. So the purpose of the charge tape lab is to observe the interactions between two charged pieces of tape, and also to use GlowScript to simulate these interactions with data obtained from the experiment. Another goal is to calculate the charge of the tape and the number of electrons that have been displaced in the tape. So for the force diagram in this experiment, this diagram on the right shows the model where the forces will be enacted vertically, the electric forces repelling, and it will be in the vertical directions, up and down, and there's also gravitational force acting on both B and A. The system would be the charge tape, the surroundings would be the charge tape holder, and the hands and the air. So the results are that repulsion between the tapes observed when near each other, or repulsion between them is observed when near each other, and that 8.75 times 10 to the 10th excess electrons was observed from calculations on the charge tape. And so some important physics ideas. So repulsion between the tapes is observed when they are near each other if there is the same charge observed on the end of the tape. And so Coulomb's law can be used to calculate these charges and the force. And you can see here in these equations that force in newtons is equal to mass in kilograms times the acceleration. And force is also equal to the constant multiplied by the two charges divided by the distance between the two charges squared. Okay, so for this experiment, the mass of the tape was measured, the distance between the tapes were measured, and the length of the tape were measured, and then the force of gravity was calculated as the mass of the tape in kilograms times the acceleration due to gravity. So then after this, Q, which is the charge of the charge tape, was solved for by rearranging Coulomb's law to solve for Q instead of F, which leads to this calculation right here, and this calculation yielded 1.4 times 10 to the negative 8th coulombs of charge on the tape. So using this value and also an existing value, which is the charge of an electron, the 1.4 times 10 to the negative 8th coulomb charge was divided by 1.6 times 10 to the negative 19th coulomb charge to yield 8.75 times 10 to the 10th excess electrons. And this makes sense because the total charge should be the total number, or due to the total number of electrons, so dividing the two should yield the number of electrons. And so for the code, you can see the necessary constants were defined, the gravitational force, the electric force, and then this code right here yielded this diagram right here, which you can see the forces on the tape. The blue would be the gravitational force, and the yellow would be the electric force. And so it also shows the calculated charge in the tape and the number of electrons on the tape. You can see the arrows shown here labeled, and yes, that's basically it. And so for the what if electrons had positive charge and protons had negative charge, so the same force and same direction is going to be calculated because the number of electrons would be the same still, and the electric fields would be the same but opposite, leading to the same force. And so for the why is it important to handle these charged tapes as little as possible, so recall that the way that the experiment was set up was the interaction between two pieces of tape which caused the excess electrons. And so this is kind of similar to what could happen if the charged tape came into contact with your hand or another object from the surroundings. Electrons could be transferred, and it could affect the experiment's values. Alright, thank you.